Hello friends. This question is given, suppose, and you have to find the value of Rx. Okay, and let us assume transistor T1 and T2 are identical. So you can apply some external voltage and you can find the value of Rx. Okay, measuring the voltage and current, that is the ratio V by I. But let us first build some concept and through which we can easily find the value of Rx. Okay, just applying some logic. Okay, so the concept is, suppose you have a transistor and let us assume the small signal output resistance R naught is very large. Okay, and let us ignore this for this particular problem. Okay, and most of the time we can approximate the output resistance as very high. So you have some base resistance RB and some collector resistance, let us assume RC. So you have some biasing current IC is flowing. Okay, you may have some voltage source VCC, and at the input side in the base you have some voltage source, but for the time being let us assume this is as ground. Okay, means in order to find the resistance Rx over here, say this is Rx. Okay, so you can let us first assume that your both RB and RC is 0, RB equals to 0 and RC equals to 0. We will introduce this RB and RC later on. Okay, so what is the value of Rx? You can draw the small signal model, that is basically GMP pi. Okay, and this is basically your RE, this is base terminal, and this is grounded, and you can apply a external voltage V and the current is I, and you can see easily from this KVL loop, that is B by I is basically equals to RE. Okay, it's simple. Now introduce the RB. Okay, so this is RB and you have this current source. Let us assume right now this is beta IB because the current IB is flowing, and you have RE resistance. So this resistance is Rx. Now you apply external voltage source and measure the current I. The applied voltage is V, and input side it is grounded. Okay, so what is the current through RE? That is IE is basically equals to beta plus 1 IB, right? Now apply KVL. So minus V, that plus I into RE, plus it will be minus IB RB. Okay, and we have IE is this one. IE is basically beta plus 1 IB. So you can write IB as IE divided by beta plus 1. Okay, and IE is basically minus I. Okay, minus I is the current from this external voltage source. Okay, so IB is basically minus I beta plus 1. Okay, and so this is 0, so you can write B plus I RE. Okay, and IB is basically minus plus I divided by beta plus 1 RB. Okay, that is equals to 0. So what is V by I? V by I is basically RE plus RB divided by beta plus 1. So now you have to observe this important observation, that your base resistance is reflecting at the emitter side. It is reflecting at the emitter side with a very low resistance, that is RB divided by beta plus 1, because beta is very large. That is why it is reflecting as a base terminal as a very small resistance. Okay, now initially when RB was not there, so this is RB was not there, in that case your Rx was RE simply. Now because of this RB, what is the emitter resistance? That is RB divided by beta plus 1. Okay, similarly you can say that if there is a resistance, say if there is a resistance RD over here. Okay, and let us assume RB is over here. So the effective resistance looking at this terminal, that is Rx. What is Rx? The Rx will be simply, if you just imagine the small signal pi model, that is RB is there. Okay, and R pi is there. In addition to that, this RE will reflect over here. Okay, RE will reflect over here, as a small resistance, that is Re divided by beta plus 1. If you just replace this BJT with a small signal T model or pi model and apply external voltage source at this base terminal, okay, this terminal, and you will get that this Rx will be basically this is Rb plus R pi plus Re. I'm sorry, this will be Re into beta plus 1. Okay, sorry, Re into beta plus 1, right? So it will be simply Re into beta plus 1. This is the effective resistance at the input side, okay, at the base terminal, okay, this terminal, input terminal, right? So any resistance at the emitter terminal is reflecting back to the base terminal with a very high resistance because of this factor beta plus 1, and any resistance in the base terminal, okay, say Rb, is reflecting back to the emitter terminal with a small resistance because of the factor 1 by beta plus 1, okay, because beta is very less. So this thing you have to remember. Now if there is a Rc, okay, so if Rc is there and Rb is also there, then in order to find this Rx, this Rc will not affect anyhow, because this Rc is connected at this terminal. This is a current source. This is basically Gm V pi or beta Ib, you can write. So this Rc will not change this current Ic. This Ic is basically Gm V pi, will not this current Ic, because the value of Ic will depend on the V pi and Gm, okay, and you have Re and you have Rb is here. So Rc is not changing your current Ic, Ib or Re, okay, so this is Ib and this is Ie. That is why this Rc will not affect Rx, right? Now Rb is affecting Rx because if Rb changes, then Ib, the base current, also changes, okay, that is why Rb is affecting Rx. So Rc is not affecting our current Ib, Ic or Re, okay, that is why Rc is not coming into the picture, okay. Rc is not affecting the external emitter resistance looking at the emitter terminal, or resistance looking at the emitter terminal, or the resistance looking at the base terminal. This true resistance is not affected by Rc, okay. But if you include this small signal output resistance R0, that time it will affect the voltage across collector terminal of the transistor. So it may affect the voltage across the emitter terminal of the resistance, and similarly it may affect the current, okay. That time Rc may come into the picture, but in general if you ignore this R0, it is not coming into the picture. So most of the time in the question you will see that the value of Va is the early voltage is infinite. You can in that case you can assume the R0 is infinite, okay. So now let us see how you can solve this particular problem. So this problem, okay. So for the transistor, both are same transistor, identical transistor, okay. So what is the resistance over here at the emitter terminal? Say Re1. So Re1 will be simply Re plus Rb divided by beta plus 1, right? This is the resistance, and you can approximately write, if beta is very large, then IE is Ic, means collector current is equals to the emitter current. In that case you can write it as 1 by Gm, okay, and so this is Rb divided by beta plus 1, okay. Now this Re1 is basically the base resistance of transistor 2, okay. So what will be Rx? Rx is basically Re2, and that is basically 1 over Gm of transistor 2, and let us assume both are same, so it is simply 1 by Gm plus 1 by beta plus 1, the beta of transistor 2, okay. So both are same, so we can assume beta is also same. So beta 1 by beta plus 1 into the base effective base resistance, that is Re1. What is Re1? Re1 is basically 1 by Gm plus Rb divided by beta plus 1, okay. So this is the value of Rx of this question, okay. So you can easily solve this particular question very easily.